All right, sorry, camera was in an odd spot. Good morning. We're in week 12. I see a couple of you out there, so thanks for being here. Good morning, that one kid. Nice to see you as always. Um, so yeah, we all gained an extra hour. All right, is that what falling back does? Yeah. Um, so anyway, we're in week 12, so we are really starting to get toward the short end of the semester, which is great. Um, so yeah, nothing really weird or different going on. This is just sort of a standard week of content, except for I'm unhappy with my camera. Maybe that's a little bit better. Um, okay, it just maybe look like I was sitting too low. Let me get in our class. Oh wait, I already have our class. It's right here. Okay, so the thing to start being on the lookout for is the distro project. So we are in the week of November 7th. So we have November 14th week is about scripting. November 21st week is about scripting, which is also Thanksgiving week, which means for some of you at least, you might lose some of the time that you would normally spend in studying. And then we have the week after Thanksgiving. So I'm just kind of pointing out to you 4 weeks, and then the distro project is due. But one of those weeks is Thanksgiving. So I highly, highly, highly recommend that you get started on that soon. You have research to do, you have installation to do, you have some exploration to do in your distribution of choice. So please leave yourself adequate time to do that. It is your one major independent project for the entire semester. Of course, we have a midterm and a final, and those are big events also, but this is the one, sort of the one out of the normal big thing that we do. So it is due in 4 weeks. One of those weeks is Thanksgiving, so please keep that in mind and get started on it soon. I did have a visitor last week in office hours to discuss it, so I was encouraged by that at least one person in our class is already starting to sort of focus in on how they're going to do the distro project. And hopefully others of you are already in progress. Okay, so let's just go step through the module and then we will... Why did it go there? Anyway, and then we'll go into the virtual machine. And now that I have a little bit of graphics, it will look a little bit nicer on the screen since I installed a couple of window managers last week. So we are talking about permissions for system administrator types. This is hugely important. And no doubt most of you have some kind of experience with permissions. This is kind of like if you think about the root user as being a user with special system-wide privileges. Now we are focusing in on the Linux way of controlling privileges on specific files and specific directories. So there's a complete permission system, as there are in most computers anymore, that allows us to control to some level of detail the permissions on individual files on the system and also individual directories on the system. So we'll look at the way the Linux does that today. We will use the ls command and its long listing option to view the permissions that are currently set, and then view the permissions after we change the settings. We will use the change mode, chmod, although I usually say chmod when I refer to it. But it's change mode, but it has to do with it's the command that we use to change the permissions on files and directories. And then we will discuss the differences between the different kinds of permissions you can set on a file and what those permissions mean to a file, and then the kinds of permissions you can set on a directory and what those permissions mean on a directory, because they are different. Having permission to read a file is different from having permission to read a directory. It'll seem obvious once we start playing around with it. It's a cool thing. It's an important thing, especially for system administrators to master, is reading and understanding permissions and then knowing how to manipulate them to have a secure system. But even if you are a developer type, you need to know how to read and understand permissions, and often developers have to change permissions for their software to work as well. Okay, so we have some readings. There's a Wikipedia one that has some extra detail that hopefully will help understand all the groupings of permissions and the kinds of permissions and the different ways that permissions affect files versus directories. So hopefully that reading helps. Lab as always, let me get the hands-on experiments open and I will go look at those in a moment. Discussion this week is preparing for the next set of demos. So this week we will look at desktop environments, which if you are a Windows user or you are a Mac user, that is all you ever know in your computing life is the complete desktop environment. So it's a graphical environment. It has lots of applications and utilities that are usually bundled with it, calculators and little games, and web browsers usually come installed. So a desktop environment for our discussion is a fancier way of having a graphical environment to do work on a Linux system. And then I'll see what you, as a group, your thoughts are about what you thought was interesting, and then I will demo 2 or 3 desktop environments, depending on how long they take to download and install. That's the discussion. And then the reminders page, lab as always, discussion as always. Please keep track of the distro project. Have that somewhere in your calendar so that you have time to sit down and do it. Installing a virtual machine can take a little bit of time. Sometimes mistakes are made and it has to be started over. So you want to leave yourself plenty of time to install a distribution, log into it, and explore it as a user. And then there's a fair amount of research that goes along with the distro project, so you want to make sure that you've left yourself enough time to do that as well. I'm going to open it. I've done a walkthrough of this before, but I will just remind you, there's this whole description. There's a list of some of the available Linux distributions that you might choose from. Last week in lecture, we talked about, for the Mac users, sort of your limited set of options that are going to be convenient for you. So if you haven't watched last week's lecture and you are a Mac user, I can recommend it at least, because I did talk in some detail about what your options are for doing the distro project on a Mac. And then very importantly at the bottom, there's this what to submit section. It has a template in it, pardon me. which so it's almost entirely fill in the blank stuff. So everywhere, hopefully it is self-explanatory, but anyway, you have this banner at the top. Of course, you put your name and the date that you completed it on there. So these little, with the hash symbol things, those are section headings. And then under each section, what should happen is you replace all of the uppercase letters with the results of the information you gather doing research on your chosen distribution. So for your report, you'll still have the basic distribution information header, but then this whole section will be replaced by specific information that you gathered. The name and version of the Linux distribution you chose to experiment with, the URL of its homepage on the web, and then a brief description of the project with some assistance about what to look for when you are gathering information about a Linux project. Then you have another heading that will remain, but then everything below it should be replaced by the results of your research. Use cases, the heading will remain, everything below it will be replaced by the results of your research. And then the last section, which is your impressions, which will be you installed it, you ran it, you logged in, you played around with package management, you looked at the graphics system, you explored the software that was installed. You sort of replace all of that with the results of your own personal experience with that distribution. All right, so I'll probably just remind you about the distro project up and including the week that it's due, but there's the template. That's the second time I've kind of walked through it, but just so no one feels like they got lost. Okay, hands-on experiments. There's no pictures this week, but I'm going to do all of these things. So we will use the ls command to look at permissions. We will use the change mode, chmod command, to change permissions on files and directories in the two ways that that command allows it. So chmod has a letters mode, which on my agenda you'll see called mnemonic. What did I say? Did I say letters or, yeah, letters. And chmod has a numeric mode, which is numbers. So we have two options for changing the permissions on files and directories, and we will look at both of those. We'll use the touch command probably to just create some files quickly so we can see what the default permissions look like on our Linux system. We will use VI to attempt to edit files that have different permissions on them, just to see what effect permissions have on files in terms of editing them. We will use the cd command to see what effect changes of permissions on directories have on things like changing directories. And then the last thing we'll do is we'll create a simple bash script. A bash script is just a simple program. You'll see it'll be a very simple program. But we'll create a bash script, and then that will allow us also to explore permissions. So we're going to do a whole bunch of exploration of permissions. And the hands-on experiments is just reminding you of the various ways that you can go about that. Okay, let me switch to virtual machine view and start looking at what permissions are. I'm going to go into my exinit RC. I don't want awesome. I think I'll use black box. So this is just from last week. So I'm editing my exinit RC to disable ICE, i3, and awesome, and I have enabled black box. So when I save this and type start X, black box will start. And since I went to the trouble to install graphics, why not use them? So I'm going to do so. Okay. And then from here, I will, what's the quick way to get a terminal? Middle button, right button, I guess. Black box. I would like terminal to be easier to get at. It's fine. I only have to get at it once. Shells, tools, viewers, tools, system. Goodness gracious. I'm looking for Xterm. which interestingly I have not found yet. Screen, help, games, black box. How interesting. I didn't... Wait, I had a terminal on here before, didn't I? Maybe I never did. Well, let's see what happens if we open a bash. Okay, so I went to I right-click Applications, Shells, Bash, and that opened it in the terminal. So okay, fair enough. I'm just checking to see if it's going to be acceptable. You know what? I don't like the black on white here. I'm going to get out of here. I want out. Oh, wait, I can switch to ice. No, I still want black on white, so I'm getting out of here. Okay. I think black on white is better for the stream and the video. So I'm going to make a folder here. Let me do a listing. All right, so I am in... it's interesting that I lost the colorification of my listings. I'm not sure why that's the case. I'm just doing a little bit of... Oh, there's why. It's probably this... No, that wouldn't affect anything, that alias. Oh well, it doesn't matter. For some reason I don't have the colorified output, but that doesn't matter. By the way, if you don't have the colors to show you directories, you can use ls with the -f option and it'll put slashes behind the directories, so I'll just do that today. I'm not sure why the colors went away. I assume it has something to do with me installing those graphics and playing around with my .bash files last week. All right, anyway, why am I here? Because I want to make a directory for week 12. CD week 12. I want a clean workspace without any files in it whatsoever. Okay, so the first thing I'm going to do is I'm going to just use touch to create a file. And then I'm going to do a long listing on it. And then describe for you the different fields that we're seeing. So starting from the far left, well, we have a total 0, which is just talking about the total size of the contents of this directory. But anyway, if we start from the left, we have a -rw r r -. So most of those are the permissions on this file1.txt. The leading dash is actually an indicator of type. So let me make a directory and just show you. I'll call it subdir1. Okay, so now I have file1 is the first listing, and then subdir1 is the second listing. And I did that to show you that that first dash on the file is a type indicator. So if you look at the subdir listing, the dash has been replaced by a D, which represents directory. There are other types. We are only going to worry ourselves about normal files, which will have a dash for the type, and directories, which will have a D for the type. But then you have 3 groupings of 3 is what those are. I'm going to put these in a file so that we can kind of break them down. But we have 3 groupings of 3. So the file1 entry starts with the dash. That means it's a regular file. And then it has rw dash. So those are the read, write, and execute permissions for the owner of the file, which is file1.txt. And then we have an r dash dash. Those second triplet are the group ownership of the file. And then the final r dash dash are the everybody else permissions on the file. So in a Unix system, you have individual user accounts. You can create groups that you connect users to. So I can be a member of various groups on the system. So you have the user, you have the group, if any, that you belong to. And then you have everybody else, which is anybody who's not a member of your group and is not you, as it were. Okay, and then don't worry about the 1 and the 2, but then you have JBoyd T. So JBoyd T, the first JBoyd T is the owner, the user account who is the owner of the file. So me, JBoyd T, I am the owner of that file, which means that RW dash to the left are the permissions for me on that file. Those permissions mean that I can read that file, meaning I can open or view its contents. I can write that file, meaning I can edit it. And then the final dash would be an execute permission, which we would need if we wanted this to be a program or a script. So since this is just a file, by default, there's no execute permission on it. So I can't execute it as if it were a program or a script. So those are the 3 permissions that go with that first JBoyd T, which is the user, the owner user. The second JBoyd T is the owner group. So on Debian systems, when you create a user account, the default is typically that it creates your user and then creates a 1-member group for you that's the same group name as your username. That's the default behavior. So there's a group on my system called JBoyd T, which I am the only member of at present. So the group permissions for us are not super interesting, although maybe we'll experiment with that if we have time. But anyway, that second JBoyd T is the group that is associated with file1.txt. And what I'm shown about the group's permissions is that the group's permissions are read and then no write and no execute. So members of this group who aren't the user owner, so if I had a second user on the system who was a member of the JBoyd T group, they could read this file, but they couldn't write to this file. So grouping is a good way, group membership is a good way to offer limited access to multiple users on a single resource on a Linux system. And then the last R dash dash are anyone and everyone else who has access to this system. They can read this file, but they can't write or execute it. So it turns out that the world or everybody else permissions are the same as the group permissions, which are different from the user owner permissions. Okay, and then we'll just quickly do that, and then I'm going to dump these in a file and break them down again. So the second listing is a directory, the D, and then it's say RWX, so that means the owner, the user owner, JBoyd T, can read, write, and execute on that directory. Executing on a directory does not mean run the directory as a program, because that makes no sense. Execute permission on a directory means that you can search through it. And that's kind of weird, because what's the difference between reading a directory, which would allow you to list its contents, versus your ability to search in and through it? So we will experiment with that to see what it means and what it feels like. And then write permission. So the W in RWX means that the owner, me, has permission to create new files here. I'm going to take some of these permissions away just to show how they work. And then the second, the R-X, means that members of the group JBoyd T, which could include people other than the user JBoyd T in it, members of the group JBoyd T have the ability to read, not write, and execute. So members of the group JBoyd T can read the contents of the directory, they can search in and through it, but they can't add new things to this directory. And then the everyone else, which we'll call others or world, everybody else has the ability to read the contents of this directory and search in and through it which is what execute means for directories. Okay, so let me do this. So perms, oh, what am I doing? ls-l redirect to perms.txt. So I'm going to dump these permissions into a file so that we can then kind of tear them down, and I can leave some notes behind for you to look at as we do that. Okay, so let's dump those in that file, and then let's go edit that file so we can kind of break it apart. I don't need this first line, so I'm going to get rid of it. Okay, so let's just tear these down. And then I'll try to line things up. So we have the type, and then we have user permissions, we have group permissions, and we have other permissions. And then we have a digit, and then we have the user owner, we have the group owner, and then we have other things. All right, so let's line those things up. The type of this file is that first dash. When there's a dash on that type field, that means that it's a normal file, basically plain text. And then we have a triplet, which is the permissions for the user. And we have another triplet, which is the permissions for the group. And we have a third triplet, which is the permissions for other, which is everybody else in the world. Then we have this throwaway digit. Then we have who is the user account who owns this file. And then we have who is the group account that owns this file. And then we have a bunch of other stuff. And then I'll do the same thing for this one. So the type on perms is regular file. And then we have a triplet representing the user owner permissions. I did something. Oh, I see. I did. I know. There, I messed up. Then we have the group owner permissions. And then finally we have everybody else, which we refer to as other when we're talking about permissions. Or you can say world. The world who's not members of my group and not me. Okay, then that digit, which we don't care about. Then we have the user owner of that file is still me. The group owner of that file is still my group. And then we have this other stuff that we don't care about just a whole lot. Okay. This last one, we have, it's a directory, the permissions for the user / owner, the permissions for the group / owner, and the permissions for others, everybody else. Hopefully I got those together. I did. And then get all this stuff out of the way. Okay. So yes, it's true. It's a little confusing that my group name is the same as my username. I will hopefully have time to add a group and then experiment with group. But if I don't today, I will come back to the concept of groups later. But we can be members of multiple groups, and file and directory permissions can be set at the level of groups in addition to the level of the specific owner of a resource, file, or directory. We can associate a group with files and directories and then have multiple members of that group who have their permissions. And then we have the set of permissions that would apply to everybody else who's not members of the group and not the user who owns the resource. Okay, so that's what those, we are most interested in those first, these three triplets here. Escape. We are interested in the user triplet, the group triplet, and the other triplet on files and directories. So what do they mean? How do we use them? So if you see a triplet that looks like this, then the file or directory has no read, no write, and no execute permission on it. For the user, if you see the dashes, the triplet there, or the group, or other, or anybody, which would be a weird thing to see, but technically you can take away the permission, all the permissions from everybody. On a resource. So this is read only, write only, execute only. So just to sort of interpret the triplets, just separate those out a little bit. So you have to know which triplet you're looking at. Am I looking at the user triplet, the group triplet, or the other triplet? And then I can take this little pattern and I can decide which of the permissions do they have and don't they have. So if it's all dashes, they don't have read, they don't have write, and they don't have execute. In fact, I should say no read, no write, no execute. Right? We can have read only, we can have write only, we can have execute only, and then we can have all of the different combinations. Did I get them all? 2, 3, 4, 5, 6, 7. It seems like there should be 9. Read, write, execute. I think that's all of them. Okay, so that's how to interpret the triplets. Now let's look at the how do we change these things. So we change these things. I'll just kind of load up some. Oops. Why is that so hard to type? Okay, so you're about to see me do some change mode experiments. And you're going to see me add and remove permissions. Gosh dang. I do want the equals. Okay. So this is the numeric style, and I'm not going to do like this giant. At some point I'll stop. So no, this is the mnemonic or letter style of changing permissions. So use the change mod, chmod change mode command, and you can either use a plus to add additional permissions, which would not change the current permissions but just add to them. You can use the minus to subtract from the current permissions. Or you can use the equals to set the specific permissions on the triplet that you want. So there's an additive plus, there's a subtractive minus, and then there is a precisely what I want all at once equals. And you can do those settings on user, group, and other, which is what the U, the G, and the O are referring to in the command. So we do things like add write permission or subtract execute permission. Or I want exactly read and write only. We can do that with group also, and then we can do that with other, and then you can also do it in combinations. So you can say that I want to change group. I want to add a permission for my group members and for everybody else. You can say I want to remove a permission from myself and my group. And then you would, say things like I want to remove executability. You can do all three at once if you want to. You could say, actually, everybody should have read-write on this resource. So these are just some examples. These would always have something on the back end of them. All right, so anyway, those are examples. And then we'll see how they work for real on actual resources, but just so you kind of get a feel for what the letter style looks like. So we use the U when we're referring to the user, the owner, the G when we're referring to the group associated with the resource, and then O when we're referring to all others, everybody else. And we can use the plus symbol if we want to add additional permissions. We can use the minus symbol when we want to subtract one or more permissions. We can use the equals symbol when we want to set precisely the triplet all at once. And then we can also refer to U, G, O in different combinations. So we could do G, O, add something. That would be add execute for group and all others. This next one, line 29, would be subtract execute from the user and the group. And then the last one would be for the user, who's the owner, for the group associated with it, and all others, set it to be read-write specifically. So we'll try a whole bunch of these on one of these files just to see how it works. This is the letter style, or the fancier word for that is the mnemonic style. So using letters to set permissions. And you specify one or more triplets with U, G, and or O. You specify whether or not you are adding permissions, removing permissions, or setting specifically the exact triplet that you want with equals. Yeah, that's everything for letters. So let's try it. So I'm still in my week 12 folder. Let's use long listings. So the first thing I'm going to do, so see file 1 there, it has read permission for everybody. I'm going to take that off. So I'm going to say chmod. So from everybody, remove read on file 1. So I'm changing the permissions on file 1. I am taking off read from user, group, and other. Before I press enter, I will note that the user has write permission in that first triplet. So in theory, what should happen is I should still see the write permission, but the read permission's all gone. And I'm going to focus the ls-l specifically on file1.txt so that we don't see the extra clutter. Okay, so there is read removed from user, group, and other. So let's do this. Let's just for the user add the read back on file 1. So there's the read back. Let's, for the group, set their permissions specifically to be read and execute on file 1. Why do I keep hitting that key? I don't know. So now you can see my G equals RX. So that set the groups triplet to be read and execute specifically. And notice because I didn't put the W in there, the W is not set. And let's say for everybody else, all others, let's go ahead and let them read the resource. So now all others have the read ability. And let's go ahead and, no, that's probably, no, let's take off execute. Let's say, oh wait, I don't want the group to be able to execute that like a script or program. So I'm going to take that away. Dang it. Okay, so now we can see that the user, the owner, which is me, has read write but not execute. The group, which is the group named after me, jboyd, and I happen to be the only member at the moment. But that could change if I added more users to my system. I could add them to my group. The group has read only, no write, no execute. And then all others, the O part, read, no write, no execute. Okay, so I'm going to clear, and I'm going to do an ls-l to remind us where we're at. So I actually put the permissions back to where they were by default. So when you touch a file, to create a new one, so touch file2.txt will create a new empty file. The system is going to apply default permissions to it. So I'm going to go ahead and use touch to create that file, and then I'm going to do another long listing, and I will notice that file 2 has those same permissions as the other two files. And what I know from that experiment is that the default permissions on my system are for the owner to have read write, but not execute, for the group to have read only, and for all others to have read only. Hopefully we'll find time to play around with changing that default, although that's really a Linux 2 issue. How do we change a system-wide default? Okay, so those were the defaults. The directory is quite different. So there is some letter or mnemonic, the fancy word, the mnemonic or letters style of change mod on files. You can do the same thing on directories. So change mod, I will, for the group and all others, I'm going to remove that read and execute from subdir 1. And now only the owner, which is me, has read, write, and execute on that folder. Nobody else. And we're gonna explore how the permissions work now, and then we'll do the numeric style, which some people find more difficult to work with. So let's talk about the implications of read, write, and execute. So I am gonna take all of the permissions off of file1.txt. So nobody has the ability to do anything. So let's see what that means when it comes to reading the file. And one way that you can read the file is with the cat command. So if I do the cat command, in theory, it should dump the contents to the screen. But I get a permission denied. And the reason is because I don't have the right to read that file. I took that right away from myself. So let's restore it. Let's put the read permission back on file1.txt. And then I will try to cat it out again. It's empty, but you notice I didn't get a permission denied this time. Because I have the read permission on it. So having the read permission means that you can do things like use cat to view it. You can use less or more to view it. It's empty, so nothing happens. So the read permission on a file is pretty critical, but it also means that if you take the read permission away, that you have gone a long way to securing the file, because now only select either the owner of the file or the group associated with the file might have the read permission, but you take it away from everybody else who's not a member of the group or the owner. That's a good security measure, at least in my opinion. Not all the security measure, but at least it is a security measure. By the way, root... the root can overcome permission settings on everybody. So root has the ultimate power to override and change permissions on everything in the whole system, pretty much. So don't forget that root is all powerful when it comes to permissions, as well as everything else. Okay, but as long as I'm the owner of a thing, I have the right to set and change the permissions as I see fit. So notice file1.txt. I do not have write permission on it. But let's open it with Vim. So I can open it, but you'll notice that there's a message at the bottom that says I'm in read-only mode. So Vim recognized that I don't have write permission on this file, and it actually makes a note of that for me. I'm going to go ahead and go into insert mode, which notice Vim is saying you're changing something that you can't write, but let's go ahead and write into it. Hello from file 1. That was fun. All right, now I hit escape. Now what happens if I try to write that file? So I'm not going to write and quit. I'm just going to write just to see what Vim does with that. Okay, so Vim is saying I'm in read-only mode, but it turns out that Vim will allow you to override. If you are the owner of a file or you are root, you can override the fact that it is that you don't have write permission on it. Better to set the permissions correctly than do this, but I can override from inside of VI by saying :W exclamation point, and then it will allow me to write it. Now, if I make another change, let's see if it'll let me write it. So again, I have to overwrite each individual thing. I'm going to go ahead and quit at that point. In this case, I'm using the exclamation points differently. So on the quit, I'm saying don't keep the changes I most recently made to this file. So Vim didn't change the permissions of the file, but Vim actually does have the tooling in it so that if you own a file or you are root, you can override your inability to write the file, meaning I don't have write permission, but Vim let me override that since I own it. I can still read it, so I should be able to cat it out. Okay, so hopefully you get the idea about that. Oh, execute. We'll see execute permission on a file when we do a scripting example here in a bit. So I'm trying to be mindful of your time. So let's look at the implications of permissions on a directory. So permissions on a file are fairly straightforward. Having permission to read a file means you can view it either with a command that's designed to print the contents of a file, like cat, more, less. Although any file, any command that needs to open the file. So let me take my read away. Any command like grep hello in file1.txt. Any command that needs to view the contents of a file, like grep to search the text inside the file, if you don't have read permission, those commands are going to fail because you don't have permission to do it. So if I put the read permission back and then try the grep again, it will work even though it didn't find a hello. Although I think I put a hello in there. I just need to be case insensitive. Yeah. Okay, so anyway, for files, read, write are fairly intuitive. You can read the contents of the file, which means you can execute commands that need to read the contents of the file. It means you can display the contents of the file on the screen. Write means that you have the ability to alter the file. And there are commands. Well, we can do another one. I don't have write permission on it now. So what if I wanted to take the date command and append it to the bottom of file1.txt? I don't have write permission, so I can't do that. So write permission is fairly intuitive, I think. You can't alter the file unless you have write permission. Now, I did show you that the VI editor actually gives you the tooling to override that when you feel the desire to do so. But better practice, I would argue, is to make sure the permissions are set like you want them. Okay, so we'll look at execute on a file as the last thing that we do, which is to develop a little script and then run it as a little program. Then we'll need execute permission. Okay, for folders, what does this mean? So let's be clear. Let me do a long listing. So it's that subdirectory that we are now interested in. So right now I can change directories into that subdir. I'm just using all of the path information just to make it clear. So change directories from the present working directory / to subdir1, which is a directory. Okay, I can do that, and I can do a listing of it. Let me go back one. I can do a listing of the subdirectory from one folder up. So that's all fine and good. I can presently change directories into it. I can do listings of it. In fact, let's go into subdir one more time. So I'm in subdir1. There's nothing here. Let's use touch to create a couple of empty files. This is for experimentation purposes, of course. So there are the contents of subdir1. Subdir1. So I'm going to go back one. I'm going to clear. I'm going to show you where I'm at, which is in the week 12 folder. I'm going to do a long listing with the indicators of directories. So there's subdir1, which is a directory, but now that you know how to read a long listing, you don't need the slash because the D over there tells us that this is in fact a directory. Okay, so let's take permissions away and see what effect those things have. So from here, I can do a listing of subdir1, and it will show me the contents. What if I take away from the user their ability to read subdir1? Permission denied. So read on a directory means that you have the permission, you have the ability to view the contents of that directory. If I don't have read on a directory, I cannot view the contents of that directory. So we better put that back. U plus R subdir1. And let's do a long listing again so you can see I have read restored. Let's go ahead and take off write and execute from it and see what implication those things have on it. So now I have read, but I don't have write or execute. Let's see if that affects my ability to list its contents. It does not. So the read preserves my permission to list or view the contents of a directory, to read the directory. What about changing directories into it? Nope, I can no longer change directories into subdir1. I absolutely cannot do that. That is a bummer. So let's, let me clear, do a long listing. So let's restore, before we do anything else, let's restore our ability to execute on subdir1 and see if that restores our ability to get into it. Okay, so you'll notice that one of the implications of the execute permission on a directory is simply my ability to enter into it, like with the change directories command. And then I'll show you one kind of weird combination of things here in just a moment. So I need execute to actually get into this subdirectory. Let me give you the long listing on the directory itself. No, ls-l all. Yeah, okay. So the top entry there, the one for dot, is the present working directory. So I have read and execute. I do not have write. So what that means, though, is, well, let's try it. Can I use the touch command to create a new file in here? I do not without write. So write means that I can create new files and folders in a directory. If I don't have write permission, I can't create content in a directory. So let's restore that ability to ourselves. So I will chmod u plus w on the present working directory, just with a dot. And then you'll see now I have read, write, and execute. And if I cycle back to my touch command, that all works. So it's actually not that bad. Read on a directory means can I even view its contents? Write on a directory means can I create new contents in a directory, either by creating files or other subdirectories. And execute controls my ability to kind of move in and out or through a directory. So now I'm going to do something a little bit weird. Let me see if I have tree here. I don't. Okay, that's fine. We'll do without. Okay, so I am going to, let's create a subfolder here. This is going to be the hard one to understand. So we've got all the basics, we got the important stuff, but let me give you this one. It's a little bit more difficult to understand, but it can be useful, especially for system administrator types, to understand how the directory tree of a system, you can actually kind of allow users to kind of blindly pass through some locations to get to others. So even if you have a folder deeper in your tree that you want someone to get at, you don't have to let them have the ability to actually alter any of the directories or files in between where they are and where they want to go to. So by that I mean, so let me make a directory subdir1. So I am in my subdir1 and I made a subdir1. So I have my home, I have week 12, I have subdir1, and then below that subdir1. Okay, so why does all of this matter? So let's say, for example, so let me go back one. So let's say, for example, subdir1 has some sensitive content in it, but subdir1, I want more people to have access to share and alter content in there. So there are permission schemes that allow me to get to a subfolder without having the ability to actually mess up the folders in between. So what we can do, at least I hope this works. So what we're going to do to subdir1 is I'm going to say, you know what? I don't want anybody to read the contents of subdir1. And I don't want anybody to have the ability to write anything in subdir1. So if I do a long listing, so the only thing I've left intact on subdir1, and hopefully this works, the only thing that I've left intact is my ability to pass through it, to execute, but that really means in this case to search or pass through it. So can I get to subdir1 even though I cannot, so I cannot view the contents of subdir1, but let's see if I can pass through it on my way to subdir1. I can. So I am able to secure the folders in the path that the user wants to travel through by taking away read and write permission on the folders. As long as I leave the execute permission there, then the user can actually pass through, kind of silently pass through those folders and get to folders where they do have permission to do things. So that one's harder to understand, but if you did follow it, that's something to experiment with. So if you need users to get to a folder that's deep in the tree, but you have sensitive content in between that user and where you need them to get deeper in the tree, you can take away their read and write permissions on the folders in between, and they can still pass through them safely, getting to the subfolders where they want to do work. It's just pretty neat. If all that seemed very difficult to understand, don't worry tons about it. Just worry about permissions on a file, permissions on a directory, and what do they mean. I apologize that I'm going to run a little bit over today. So let me get back into my perms and add another section here. So now let's do number style of changing permissions. Okay, so we can also use a numeric style, and it's often going to look something like this. So the numeric style is, I think, harder. Maybe some people find it easier, but I think it's harder when you first encounter it than the mnemonic style. The letter style is a little bit more intuitive because I can just say I want to change that user triplet, or I want to change that other triplet, or I want to change the user and group triplets by adding, removing, or setting specifically what I want that triplet to be. The numeric style is always, I guess I can put that as a note. The numeric style is always all permissions on all triplets at once. So when you are using the numeric style, you have to know exactly what permissions you want for all three triplets all at once. So it's a little bit less flexible than the letter style, because the letter style lets you target specific things that you want to give or take away. The numeric style means that you got to know everything just as you want it when you run the command that way. All right, so how does let me move this up on the screen a little bit. So we're talking about the numeric style. So how does this work? So for each triplet, the values are four when you want to give read permission, 2 when you want to give write permission, and 1 when you want to give execute permission. So it's always 4, 2, and 1. So how does this work exactly? So example, I want to give read and write permission. So I have 4, which is read, plus 2, which is write, equals 6. So if I want to give read and write permission, I take the 4 for read and the 2 for write, I add them together, and that's the permission setting that I want. Here's another one. Let me copy that. If I want to give read, write, and execute permission, that would be 4 for the read, 2 for the write, 1 for the execute, and I get 7 total. If I want to give, if I want to give no permission, I don't have any value there, I just give 0. I'll do a couple more. That is 1 only. Okay, so you just do a little bit of math. It's not hard math. So now let me do the kind of one extended permission, and then I don't like this. So let's do a larger example. So I want if I want this, so if I want to give RWX for the user, then I get 4 plus 2 plus 1 equals 7. If I want to give read write only for group, I get 4 plus 2 is 6. And if I want to give read only for other, that is 4. So let me move these over so they line up. So the command would be for that scenario. So if I have a resource where I want to give the user read, write, and execute, well, I take the 4 for read, the 2 for write, the 1 for execute. I add them up, I get 7 for the user's triplet. If I want to give in that same setting read and write for group, then I take the 4 for read and the 2 for write. I get 6. So the second digit for the group part is 6. And then if I want all others to have read, then I take the 4 for read, and that is my settings. So I would end up setting the permissions on that file to be chmod 764, 7 for the user combo, 6 for the group combo, 4 for the other combo on that file. And the trick is you can't, you have to compute the whole permission setting when you use the number style. You can't just sort of add in extra things. If you, well, we'll just do let's just do an example right now. So let's do file 1 again. So we have read only. So let's just see what happens if I say, for example, well, I want to add write permission for the user. So I'm going to pass in a 2 for the user and nothing for anybody else on file 1.txt. So notice that the write went away. So when I say you have to set them all at once, if you want to preserve the read, sorry, the read went away. If you want to preserve the read, then you have to add the value for read in. So if I want the user to have read and write and nobody any other permissions, then I have to say, I want the user to have read, which is 4, plus write, which is 2. I want the user to have 6 and no permissions for anybody else. Now, what if I want to add read and write for my group? So to add read and write for group, I have to be careful that I preserve what I want the users to be, which is still read and write. Then I'm going to change the group by having read plus write, which is 4 plus 2, which is 6. And let's leave all others at no permissions. So that's what I want. So notice you have to preserve by making sure that you add up the numbers properly to preserve the permissions. You can't just selectively add and subtract like you can do with the letter style. And then finally, let's say that we want a read permission for all others. So I'm going to have to preserve the read and write for user, preserve the read and write for group, and then add the read ability for all others to that file. And now I have the permissions ostensibly that I set out to execute. Okay, so there's questions, and for hands-on experiments, what I recommend is that you use the touch command or the make dir command. You create files and folders, and then you use the different ways of using change mode, chmod. Use the numeric style, use the letter style, and then see if you can kind of anticipate the results. It doesn't take very long, but it does help. Like, okay, I want RWX, RWX, RW. How do I do that with letters? How do I do that with numbers? And then see if you get RWX, RWX, RW, right? So that's how I would do those experiments. You can just start by wiping off everything from a file and then adding things in, either with letters or with numbers. But you can always then kind of just use zero out the permissions and go back. That same command, by the way, can be affected like this. Right, remove, write, read, write, and execute. Take those away from user, group, and others. It's the same command, same result. Okay, So I think I'm okay on my agenda, except for I lost my mouse pointer. There it is. Yeah, okay. So we're going to do our first little tiny bash script. And then that will allow us to explore the purpose of the execute bit on files. So I'm going to make a script in here. First thing I'm going to do, though, is I'm going to say which bash. Okay, and you're going to see me do something weird, and I will explain it in more detail next week. But I need to know where bash lives on my system. Okay, so let us create a file. I will just call it hello.sh, and I'll leave that for a moment in case anyone's following along. So hello.sh doesn't exist yet. By the way, I know that it's going to be created with the default permissions of read write for user, read for group, and read for other when Vim creates it. And the .sh is not required, but I'm using that as a way for me to quickly and easily identify what my shell scripts are. So in our class, I'm going to use .sh as the, what's the word I'm looking for? The extension for my shell scripts. And then you'll see why I did which bash here in just a second. All right, so I'm opening it up and I'm going to create my first shell script. Okay, so the first thing we're going to do in here is we're going to do what we call the shebang. The shebang. Why is that key getting in my way? Shebang /user/bin/bash, which is what I saw when I did which bash. So the shebang here is so that when we write a script for the bash shell, we are guaranteed that it will be executed in a bash shell. Since Linuxes have many shells available to them, when you are writing shell scripts, you may have a user that takes your shell script and tries to run it in a different shell, which may or may not be able to execute your script correctly. So this shebang line guarantees that the script that we write will be executed by a bash shell so that we can use the scripting features specifically of the bash shell. So I'm writing a bash script. That's what the shebang means, right? This is a bash script. Okay, so first thing we'll say is echo hello from the script. So we'll just start our little script, our little kind of program with a print statement to the screen that says hello. We can also execute the date command here. Why not? And why not execute cow save from here? Hello from a cow. That's probably enough for a first script. So what do we use shell scripts for? We use them to execute commands non-interactively. So by non-interactively, I mean when this script executes, the echo statement will run, the date command will run, and the cow save command will run. All three in sequence automatically without me having to type them in separately. And the shebang line means that this is a bash. This script is meant to be a bash executed script. All right, hopefully that's enough time where I can write and quit. I'm going to clear, and then I'm going to do a long listing on my script. So it has the default permissions on it. So to run a script, you type the name of the script, but don't do this yet because I'm going to do it and show you errors. So, okay, I'm going to type the name of the script. Command not found. Why is the command not found? Because hello.sh is not on my path. So when I type something that looks like a command to the shell, it's going to go look in my big P path to see if it can find it. Now it turns out that this folder I'm in, week 12, is not on my big P path, which means that when I tell the shell to go find hello.sh, the shell says, that's not a command on your big P path. Fair enough. So how do we execute a script if we create scripts that aren't on our big P path? Well, we can tell the shell it's the script in this folder. Or if we want to, we can say, starting from root, you can get all the way here. Right? So I can tell the shell precisely where this command lives on the system, and it doesn't have to look in my path. It's going to go through those folders to find, oh, hello, not shell. Or I can, since I'm already in that directory, I can much more quickly just say, it's the hello.sh that's in this folder. Now I get a permission denied. So this is a good thing on Linux, that by default it will not execute things. If you want Linux to execute commands in a file, you have to make the file executable. So how can we do that? Well, if we do a long listing on it again, we'll see that I do not presently have execute. So I'm going to give myself the execute permission. Now there's two ways I could do this. The number way would be to note what my permissions are right now, which is read and write, which is 4 plus 2, which is 6. And then to add the execute, I would say, okay, I want my permissions to be 7 actually, which is read, write, and execute. I want to preserve the read for group, and I want to preserve the read for other. So that would be a way for me to add execute permission on this file without messing up the other permissions. The way I would normally write this, though, is simply to say I need the ability to execute this file. So I like the letter style for this because all I'm doing is saying I want to flick on that executable permission for myself on this file. So this is the way you'll normally see me do scripts, is to say I want to add execute for the user only. And now if we do a long listing on it, we'll see that now I have the execute permission, so that now when I say in this folder, there is a script called hello.sh, which is executable. The shell will execute the commands inside. So there's my echo hello from the script. There's the date command being executed and shown its output. And then the calsay command with hello from a cal. Very exciting. But it is kind of exciting because we just wrote a bash script, which is cool because that's what we're going to do for the next 2 weeks, is write bash scripts. Okay, let me look at my agenda and make sure I didn't leave anything out. Yep, okay, so it's all there. The discussion note at the bottom of the agenda, which hopefully you can see, you can. The discussion note is just there to call your attention to it. And also that when you are doing your work for the discussion this week, that you keep it in mind that I will try to use your preferences to develop a demo of a few systems. So if there's a desktop environment that you'd like to see, please make sure that it's clear to me that you would like to see it, and I will do my best to work it into my demos next week before we start doing some shell scripting stuff. So anyway, that's why that's there. Desktop environments tend to be things that people get very interested in because it's the full graphics environment with lots of tools and utilities in it. And that's kind of what we're used to, and it's kind of fun to get one of those up and running in our Linux system. Okay, I think that's it for me this week. Thanks for being here. For those of you who could be here, thanks for watching if you're watching later in the week. I hope you all have a good week, and I will see you on Monday morning next week. So this is week 12. Next week is week 13. Don't forget the distro project. We will have normal content the week of Thanksgiving, so please plan accordingly. Or review a syllabus policy to note where I've given you some leeway in terms of skipping assignments and getting them automatically dropped. Either way, please keep it in mind. Thanksgiving's coming up. The distribution project is coming up. And we don't otherwise kind of interrupt our flow. We just keep going through all of it like normal. Okay, have a great week.